This is section 3.4, the chain rule. In this section, we will be discussing the composite functions and how we can find their derivative. So if g is differentiable at x and f is differentiable at the function g of x, then the composite function of f and g can be written in this way: f at g of x, it's going to be differentiable at x, and f prime can be given by the product. So basically we will differentiate f at g of x and then multiply it by the derivative of the g of x. Let's have a look at this example where we have to find f prime at x. F at x is going to be the square root of x squared plus 1. So this can be considered as a composite function of f and g, considering that g of x is x squared plus 1 and f at g of x is going to be capital F equals to x squared plus 1. So this can be written as x squared plus 1 power 1 over 2, and we know that this is g of x. To start by, we have to find the derivative of g of x. So g prime of x is going to be 2x, knowing that the derivative of 1 is 0, and f prime at g of x is going to be 1 over 2 multiplied by this g of x, which is x squared plus 1, power negative 1 over 2. So f capital prime of x is going to be f prime at g of x multiplied by g prime of x. And this basically will give us 2x multiplied by 1 over 2 times x squared plus 1 power negative 1 over 2. And here we can cancel these out. We can write it in another form, x over square root of x squared plus 1. Let's have a look at this example. We should differentiate y, which is sine x squared, and y, which is sine x squared. Let's see the difference between them. Starting with part A, we might consider the g of x to be this angle right here. So x squared is the g of x, and we might say that f at g of x is the y, which is sine at the g of x, which is x squared. So to find the derivative of this, we should first differentiate g at x. This will be 2x, and f prime at g of x is going to be basically cosine of x squared, because we know that the derivative of sine is cosine and it's at g of x, so this is what we get. Now y prime is going to be their multiplication, 2 of x multiplied by cosine x squared, and this is the answer. Now part B, if we want to differentiate y equal to sine square x, we might consider the g of x to be sine of x, and f at g of x is going to be sine of x power 2. So because f is at g of x, to start by, we should differentiate g. It will be cosine of x, and we know that f prime at g of x is going to be 2 sine of x. Now to find the derivative of y, we just have to multiply them, and we will get 2 sine of x multiplied by cosine of x. And this is our answer. Let's have a look at this concept, the power rule combined with the chain rule. So if n is any real number and u is g of x differentiable, then the derivative of u power n is going to be n times u power n minus 1 multiplied by the derivative of the g or the u with respect to x. So basically this is when we have the chain rule combined with the power rule. This is what we get. If we want to find the derivative of a function with the power n, it's any real number. So what we have to do is to put n down, this one, and here we have g of x, the base stays the same, power n minus 1, we multiply it with g prime of x, so the derivative of the base. Let's have a look at some examples. So if you want to differentiate this using the power rule and chain rule combined, so basically we can consider that g of x is x cubed minus 1. and basically g of x power n is going to be y, which is x cubed minus 1 power 100. So to find the derivative of this, basically we'll start with, we will put here 100, and then we write g of x, or x cubed minus 1, the way it is, and then the power is 100 minus 1 multiplied by g prime of x, and g prime of x is basically 3x squared. So this will be 3x squared, and this will become 3 times 100 is going to be 300, and I can put x squared here. So here we have x cubed minus 1 power 99, and this is the answer. Let's have a look at this example. We have to differentiate and find the f prime at x if f at x is this function. So basically this function can be written in another way. We can write it as x squared plus x plus 1 power negative 1 over 3. So this is the third root, and it was in the denominator, so if I take it up to the numerator, I should get the power negative, and 1 over 3, it's because it's the third root. So basically now we can consider g of x to be x squared plus x plus 1, and f of x can be written as g of x power n, and n here is negative 1 over 3. So basically we will differentiate using the rule we just saw now. Now to find the derivative of f prime of x, we should first get g prime of x. So g prime of x is going to be 2x plus 1. F prime of x is going to be n, we said, multiplied by g of x power n minus 1 multiplied by g prime of x. And here we know that n is negative 1 over 3, so this will become as negative 1 over 3 multiplied by x squared plus x plus 1 power negative 1 over 3 minus 1 multiplied by 2x plus 1. So this is what we have here, 2x plus 1. And this can be written as negative multiplied by 2x plus 1 over 3. And then we have here x squared plus x plus 1 power negative 4 over 3. Let's have a look at this example. We have to differentiate this function, and if you just have a look at this expression, here we have this expression and this expression multiplied, which means that we should use more than one rule. We have to use the product rule and also the chain rule and the power rule of differentiation. So to start by, we have to find the derivative of each of these expressions. The derivative of this, let's call this f of x, and let's call this g of x. Now f prime at x is going to be, as we have seen earlier, 5 multiplied by the 2x plus 1 power 5 minus 1, which is 4, multiplied by the derivative of what's inside, which is 2. Now we have to differentiate g of x, so g prime of x is going to be 4 multiplied by the expression x cubed minus x plus 1 power 3 multiplied by the derivative of what's inside this one. So the derivative is going to be 3x squared minus 1. Now to write y prime, we know that the product rule is going to be f prime of x, g of x plus g prime of x multiplied by f of x. So this will be y prime equal to f prime of x, what we found here. We can multiply 5 and 2, so we will get here 10 multiplied by 2x plus 1 power 4 multiplied by g of x, which is x cubed minus x plus 1 power 4 plus the derivative of g of x, which is 4 times the 3x squared minus 1 multiplied by x cubed minus x plus 1 power 3 multiplied by f of x, which is 2x plus 1 power 5. Let's have a look at the last concept in this section. So to differentiate a constant raised to the power of x, the derivative is going to be itself multiplied by ln of the base, or the constant b. If we had the function to be 2 power x, then its derivative is going to be 2 power x itself multiplied by ln of the base, which is 2. Let's have a look at the last example in this section. So in this case, we're going to use the chain rule method since we have a composed function. So this can be considered as g of x, and we can call g of x to be cosine at tan of x. And we might call the rest h of g of x is going to be sine at the g of x, which is cosine at tan of x. So basically this is f of x. Now to find the derivative of f of x, we should find the derivative of this multiplied by the derivative of h at g of x, as we have seen. So g prime of x is going to be the derivative of the angle, which is secant square x. So the derivative of tan of x is going to be secant square of x. And we know that the derivative of cosine of x is going to be negative sine, but this will be at tan of x. So this will be at tan of x. So here we can write it as negative sine at tan of x multiplied by secant square of x. And to find the derivative of h prime at g of x, so we know that the derivative of sine is going to be cosine at this angle, which is cosine tan of x. Now to write f prime at x, it's going to be the multiplication of g prime at x and h prime at g of x. So this will be negative sine at tan of x multiplied by secant square of x multiplied by cosine of tan of x. And here we stop.